Roll cam. Woo, woo, woo. Everybody on camera. There you go. Yeah. Yeah. Oh, yeah, you can hear me on there. That should be good. Oh, that's much better. Boop. All right. So weekends. How are those weekends? Hopefully you guys are rested and ready for a kind of a 4-day week. Wednesday, you don't have any new material coming at you. We already talked about that. And then next week, you have a 4-day week because actually it's more like a 3-day week in some ways, but 4-day week because you have next Monday off. So that's kind of cool. So let's hear about those weekends. Let's hear what fun stuff you did, Dylan Damiani. You didn't do anything fun at all? Okay. Nothing fun at all. Miss Ford. Was it crowded?
Not really.
No. Had it been a long time since you've been there?
I went last September.
So you went when you say last September, you mean this past September? This year?
During COVID.
Oh, okay. All right. Yeah, COVID. All right. Kevin.
Homework and gaming.
All right. Krista's not here. Grace.
I learned about pagan traditions for a holiday in Germany.
Whoa. Holiday. What German holiday is this?
May Day.
May Day. Wow. All righty. Were you amazed? A little bit?
It's a weird, complicated thing that it's half a Holy Saints Day and half a pagan holiday. It's
Wow.
weird.
Oh, that sounds like an interesting one. Wow. Owen.
I had some friends over.
Had some friends over. Andrew. You slept in what? And ate. Okay. Did you do more sleeping or eating? Sleeping. Okay. Brady.
I just hung out with some friends and watched the Super Bowl.
Sounds good to me. Noah.
Just watched Super Bowl.
Ty.
Super Bowl and hung out with friends.
Super Bowl and hung out with friends. All right. Samuel. Ryan. Had people over. Riley. Watch the Super Bowl. True is not here. Caitlin.
I worked during the Super Bowl at a pizza place with a bar. It was very busy.
Yeah, or Milano's?
I work at Dewey's.
Dewey's. I love Dewey's. I haven't been there in a long time though. Was it busy?
Yes.
Was it busy carry out? Is that what it was more busy of, or people coming in actually sitting down?
It was kind of both. I'm a waitress, so I was front and dealing with people.
Sounds like it. Stacy. Hung out with a friend. All right. Did you have to work?
Yes.
Okay.
Saturday.
I was gonna say, I'm used to you saying work.
Yeah.
Work.
That's all I ever.
All righty. Well, you know what it's time for? A quick quiz.
Yes.
5-question quick quiz. So you need to clear off those desks. For those of you who are online, okay, for those of you goons that are online, you're going to see this show up in the Google Classroom. Okay, and I'm going to post it to you guys first, and you have 5 minutes to finish it. That is it. 5 minutes to finish it. That's it, man. It's quick. It's a quick quiz. It's a quick quiz, and you guys in here are going to have 5 minutes to finish it as well. So let's see, those goons, they're going to get it at 9:50. Bloop. And that's when it's due. It's going to be due at 9:55. 9:55, and they're going to get it today at 9:50. So for you people that are online, in 2 minutes, you're going to see it post, and you will have 5 minutes to turn it in, and that is it. It's a CAMI assignment. That's for you onliners. Okay, so I'm going to assign that to you. As I said, you will see it in a couple minutes. It's just going to show up. So go to the Google Classroom and be ready, waiting and watching for it. Okay. So now you guys can take a live version of it, and you guys are going to get 5 minutes as well. And like, if it takes more than 5 minutes, that would be a problem. It really would. Okay, 5 questions. And there are the things that you don't have computations for. They're just writing down the answer. So there is no computation involved. So when you're done, you can just turn it over at your desk, and then I will collect it from you. I'll do that for you. got about a minute and a half in here. Thirty seconds left. Whoa. Whoa. Over here. I'm going to mute myself so they can't. La, do, 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 do. Shoo, do, do, and let's see, I think. Oop, that's not what I wanted. That is not it. All right. So we're going to do these. Where are they at? Aha, here it is. We put this up on the old board. Smart notebook. Why can't I see that? There we go. For you people at home, you should have out your work. See how you did on these when we go over them. Where's it going to print it? Where's it going to print it? Do, 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 do. There we go. It's coming over here. La, da, 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 da. You guys don't seem like you're very energetic today. What's wrong? You guys need to get a little pep in your step. Do, 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 do. Okay, let's take this over here. And we're going to do these. Oh, we're going to do these problems together. All right. let's see how we did on this. Let's move this up here. Starting off, of course, with number 2. I asked you guys to give me exact answers on these, okay? Exact answers. So this one here would just be log base 3 of 17 equals x. That's the exact answer right there, okay? And then if you evaluate it, of course, you get an answer. But I just wanted you to go ahead and give me an exact answer. So I wanted you to solve it for x, not plug it into a calculator at all. Number 6, let's go ahead and do number 6 since we're moving down this way. So here, my first step would be to write this in exponential form. So this would be 10 to the 12 equals 4t. So t would be equal to 10 to the 12th divided by 4. Those two are just changing forms for us. Yeah. That on letter T you did?
Yeah.
You could just, if you did that, I would give you credit. You could just leave it like that. That's fine. Okay. Number 8. Okay, again, we're going to, since it's already a logarithm by itself, I'm going to just go to exponential form. 10 to the 1/2 power equals x plus 3. So x would be equal to 10 to the 1/2 power minus 3. Or if you want, you could write that as the square root of 10 minus 3 like this, or negative 3 plus radical 10. A lot of options. Okay. Any of those would be fine for number 8. I'm going to do, is that all I had in the front? Oh, number 10, my bad. So on 10, my first step is I need to condense the left-hand side. I have to have a single logarithm right now. Product property. This is going to be common log of, and I'm just going to multiply this out. So it's going to be distributed, t squared plus 3t equals 1. Write it as an exponent. That's going to be 10 to the first equals t squared plus 3t. So t squared plus 3t minus 10 equals 0. Factor it. t plus 5 minus 2. So this would give me t equals negative 5. And this would be t equals 2. And then when I go back up here to the original equation, what do I notice? Negative 5 does not work. That's extraneous. So the only solution then is t equals 2. Okay. So anything on the front page you want to ask about?
We also had number 4 to do.
What else did you have?
Number 4.
I didn't do it? Oh my gosh, how silly of me. Number 4. Great. Here we go. 4, exponential. So before I can change to logarithmic form, I need to get the base with the exponent isolated. So subtract 29 from both sides. So I get 10 to the t, and get to plus 12 equals, and then 74 minus 29, that would be 45. Now I can write it as a logarithm. It's base 10, so I'm going to write the common log of 45 equals t plus 12, which means t is the common log of 45 minus 12. Okay, anything on the front now you want to ask about that I did? Okay? We're okay with all those? Yes? No? Yeah, nobody's asking anything. Okay. Let's head to the back. Let's go to the back. So on the back, I'd ask you to do 11 to start. Okay, so 11 again is another sum of 2 logarithms. So I have to rewrite as a product. So here I'm going to get log base 2 of t squared. The middle terms are going to drop out. These are conjugates when I multiply them. Minus 1 equals 5. So now I can write it. So it's going to be 2 to the 5th equals t squared minus 1. here, I could do t squared equals 2 to the 5th minus 1, or plus 1, my bad, not minus, plus. I'm going to go a little further with this one because I still haven't solved, haven't solved it for t all the way. 2 to the 5th, I should be able to do that in my head. I should. 2 to the 5th is 32. So I get t squared equals 32 plus 1, which means t squared is equal to 33. Now, do I want both the positive and negative root on this problem? Do I want a negative root? If I put a negative in here, is it going to work? So I only want the positive root. So it'll be radical 33. Is that one okay? Yeah.
If we still had it as like the t squared equals 2 to the 5th plus 1, would that still work?
It would. If you took the square root of both sides, yeah. Since I asked for that, that's fine. Let's see here, 16. Let's do this in purple. Purple. Okay, so now this one's different. Okay, I have logarithms on both sides, but they're not by themselves. So what I want to start off by doing is getting my logarithms on one side so I can then condense them. So I would have to add a log base 2 of 2 minus x to both sides. Literally my first step here. So on the left-hand side, I'm going to get log base 2 of negative x plus log base 2 of 2 minus x. And then now that's going to be equal to 3. Now I can go ahead and do what? Condense the left-hand side. When I do this, I'm going to get x squared minus 2x on the inside. And I wrote it in descending powers. I want it that way. So I just distributed this through. That's going to be a minus 2x and a plus x squared. There it is. Equals 3. Exponential form. So I'm going to get x squared minus 2x equals 2 to the 3rd. Now 2 to the 3rd is 8. So I get x squared minus 2x equals 8. So x squared minus 2x minus 8 equals 0. Factor x minus 4 plus 2. So my solutions are x equals 4 and x equals negative 2. And then, of course, when I look up here, what do I notice? Is 4 going to work? No and no. Make this negative 4, makes this negative 2. So 4 does not work. Does negative 2 work? Yes, because what do I get here when I plug in a negative 2? Positive 2. What do I get over here? Positive. It works. So this time, even though my solution here, x was negative, when I plug it back into the original equation, it does work. Okay? It does work. Okay. Woo! Number 16. Beautiful. Number 14. Okay, 14 was not the sum of two logarithms, but the difference. That means I have to apply not the product, but the quotient. So I can condense the left-hand side as log base 2 of t plus 1 over t minus 1. T plus 1 over t, I'm going to just rewrite that. Okay, there it is. Now I can write it as an exponent. Equals, okay. 2 to the 3rd, that's 8. So now 8 is equal to t plus 1 over t minus 1. How do I solve this? Yeah. Yeah, multiply both sides by t minus 1. You literally multiply the left and the right by t minus 1. Cancel. So now I have to distribute it. 8t minus 8 equals t plus 1. I'm going to subtract a t from both sides and add an 8 to both sides at the same time. I'm allowed to do that. Crazy. 7t is equal to 9. Therefore, t is equal to 9/7. Does it work in the original equation? If I plug it in here, do I get a positive? Yes. If I plug it in here, do I get a positive? Yes. Is there anything about number 14 that's bothering you? No? Okay, okay. All right. Now, the extra one was much more difficult. That's like that one I did on Friday with you in the notes. Okay, it was like the one I did Friday with you in the notes. All right. So I have a couple options here of how I want to approach this. Okay. Again, my choice. So I'm going to take log base 6 of both sides. Is that okay with you? I'm going to do this. All right, so now once I've done that, the right-hand side I get what? 2x minus 5, because that's what number 5 in the quiz was all about right there. On the left, I can put the x plus 4 out in front. Okay, now I want to go ahead. My goal is to get my x's on one side. So I'm going to start by distributing on the left. I'm going to distribute through. So I'm going to get x times log base 6 of 3 plus 4 times log base 6 of 3 equals 2x minus 5. Is nobody okay with what I just did? Does anybody need to ask me something at this point in time? No? Okay. Now I want to get my x's on one side. Does it matter what side I put them on? Of course not. I'm going to put my x's on the right-hand side. I've just chosen to. I don't know why, I just want to. So if I put my x's on the right-hand side, I'm going to have to subtract an x log base 6 of 3 from both sides. And then at the same time, I want to get that negative 5 off the right. I'm going to do what? Add 5 to both sides. So I can do those at one time. There's nothing wrong with that. On the left, I get 5 plus 4 times log base 6 of 3. The order I write those does not matter. On the right, I get 2x minus x times log base 6 of 3. On the right, factor out the what? The x, so I can have one of them. So I get 5 plus 4 log base 6 of 3 equals x times 2 minus log base 6 of 3. Final step, divide. So what's x going to be equal to? X, whoa! x equals this 5 plus 4 log base 6 of 3 divided by this 2 minus log base 6 of 3. Okay. And since x is an exponent, it's in the exponent, I'm not too worried about being positive or negative. You don't like those problems as much, do you? I can tell. You guys don't like that as much. Okay. So ignoring the extra one right now, which is a step way above. What about the other ones? How are we feeling on those? So on your paper, here's what I want you to do. At the top, by your name. On a range of 1 to 10. 1, I have absolutely no idea how to still get to your classroom, Mr. Snyder. And 10 would be, I understand this, the tops, I could teach it to the class. Write down where you feel like you are on solving these that we just did here. And not the extra one, everything but the extra one. How did you feel about the ones that were not the extra? I just want to see what you think you are at right now. I'm just going to walk around and take a little peek at those. Right. Okay. Right. Okay. Okay. All right. So here we go. Let's go back to the front. And let's all try number 9. Okay, try number 9 on the front. So right now, everybody's going to try number 9. I'm going to rewrite it down here because we're going to have more room for it. No. She can tell me that or not. Okay. Let's keep going with this. What do you guys want me to do first? Just somebody tell me. What should I do first? Condense, okay? Fine, I'll condense the right. So 1 equals log base 4 of, and when I do this,
That
what
should
am I
be
going to
3
end up
plus
with?
X.
What's that?
That should be 3 plus X.
Is it? No, it's not. Isn't that a
It
minus
says
or is it a
it-
plus on yours?
On ours, it says plus.
Really? Oh, wow. I'm sorry. Okay, I'm glad you. That's weird. Must just be so faint on mine when I made that up there. Okay, so here we are now. So what am I going to get in the parentheses in? 6 plus 2x. That's a distributive. All right, now what?
Exponential.
Exponential form. What is this going to look like when I put it in exponential form?
4 to the first power.
4 to the first power, which is 4, equals.
6 plus 2x.
All right. Now we're just solving a linear equation.
-2 equals 2x.
Thank you very much. -2 equals 2x. So x equals -1. And then, of course, I go back and I say, does that work? Don't have to worry about it here. Is it okay here? Yes, it is. There it is. Done. How do we feel about that one? Good? We did good on that problem? Yeah? All right, let's go to the back. All right, on the back. Let's try number, Sam, you want 12 or 13? 12. Let's do number 12. Number 12. And that'll take us into break. Okay, at 21. So when we come back from break, we'll actually do this. Let's check here. Oh my goodness. Feel free to take your break, guys. You don't have to sit in here and work. Oh. Okay, nothing there. Close this. Close that.
Do you want this?
What is it?
Smoked salmon bagel.
It's been outside, so it might need to thaw a little bit.
Oh, I'm good. I'm good. Delicious, I'm sure. That's Anne Marie was just talking about one of those.
She was like, "Hell, I gave her one."
She was like, "They're so good."
She was like, "Shane's getting it."
It's all Shane's. Oh no, it's better. Got any more plans?
I'm gonna do this in
Give it a pulse, give it a color.
the only thing I'm gonna color is the cloud.
All right.
What are you doing?
All right. We ready? First step. Condense the right using what property? Quotient. So I'm going to get -2 equals the common log of what's going to be on top? 2. All right. Exponential form. What is it? 10 squared equals 2 over 3 plus x.
That's it.
Is it a
Negative. It's 10 to the negative second.
Oh, thank you. 10 to the negative second. So now I get 1 over 100 equals 2 over 3 plus x. Yeah. Cross multiply. It's a proportion. That's what you guys probably were taught to do. Okay? So I'm going to get 200 equals 3 plus x, which means x equals 197. How are we feeling? Is that okay? Now, there was a couple I said we were going to wait until Monday. We're actually going to hold those off until Tuesday because I don't want to do that yet. All right? I think what we'll do, decided to just type up some extras. Why not? We're not room there. Okay. So you that are online watching, we're now breaking out the new worksheet of problems. All right. So again, I'm not going to have you do all 15 of these. So I think, and I would like to have you go over these by the end of class is what I'd like. I'd like to give you a time to work, ask questions right now, and then go over them, okay? So I'm going to give you some to do right now, and then I'll probably give you some for homework as well. So in class right now, let's have you do numbers. And again, I want, it says round all decimals to the nearest 10 thousandths. I want you to go exact first and then round. So you should have an exact answer and then approximately, because I want you to practice finding logarithms on your calculator / Desmos if you need to. So you're going to do both, exact and then to the nearest 10 thousandths. All right, let's go with number 1. We're going to zigzag 4, 5, 8 on the front. Oh, I like 7 too. Let's do 7 on the front. So 1, 4, 5, 7, 8 on the front. On the back. On the back, 9, 11, oh, I don't know, 13 and 14. Let's do those. We'll go over those here. I'll give you, how about I give you maybe, I don't know, 25 minutes. And then we'll start going over those. If you get caught along the way, you can come up here real fast. If you want to ask me a question, feel free. Okay. I'm going to just write down what we're doing. for the onliners. Whoa, not rock sheet. I don't think that's the correct spelling of that. The heck? Doo-doo-doo-doo-doo. Let's see what I got on here. Last year. Oh, block. This is beautiful. Yeah, I love that. That's a good one. Do I have? You guys are so quiet. No asking for any help. If you want to know of any, if you have an answer right, you can ask. I have them here. Check anything you want. Bum, 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 bum. Do, 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 do. You guys have any questions? You're so like you're working hard. I also want you to take advantage of having, you know, the chance to ask questions while you're with me. All right. You guys want some answers yet? How about I put the front ones up there to start? We're just going to put the answers to start. And if you want to see any of them, I will gladly do them. Six, 5. Those are the answers to the front. Yeah, I'm gonna- Yeah. Huh? How did you number one? Just curious. We have two algorithms that are equal, the same, basically just the next one's super rate and so. Yeah, I would say. Yeah. That's how you number one. Came back. Base what? Alt base 4. Alt base 4. Yes. That's it. That's it. All right, I'm going to go ahead. I'm going to look down here at number 7 to start. I'm going to pull this answer side. All right, so when I'm looking at this, the first thing I notice on number 5 is I can rewrite them with the same base. So I'm going to write 25 as 5 squared raised to the 2x equals 5 to the x squared minus 12. So I get 5 to the 4x equals 5 to the x squared minus 12. If the bases are the same, so are the exponents. Set them equal. So we don't want to just think that remember, we don't always have to use logarithms to solve exponentials. If I can make the bases the same, that's my goal. So now it's just 4x equals x squared minus 12. So it's x squared minus 4x minus 12 equals 0. And then it's all about factoring. So it's x minus 6 plus 2. And here, what's nice is that since that's an exponent, I don't care if it's positive or negative. Doesn't matter. All right. Is there anything else in the front you want to look at?
Number 4.
4? Okay, number 4. I've got 2 logarithms of the same base being added, so I want to condense them. So So that's going to be the common log of x squared plus 15x equals 2. And now when I'm down to a single logarithm, I go exponential on it. So it's 10 squared equals x squared plus 15x. So that means that x squared plus 15x minus 100 equals 0. Square it, move it to the other side. Is that okay so far?
Yeah, I just couldn't find what the x's would be.
What the
Like what you would
what would you multiply on that one? So when you think of -1, when you think of 100, I mean, I'm just going to start with these, okay? Now I know one's positive and one's negative, and I know my larger value has to be positive, correct? So this could be an option, okay? Now, in order to get other factors from this, I could divide this by 5 and multiply this by 5. If I did that, what do I get? 20 and so watch what I do. Divide this by 5. Multiply this by the 5 you factored out, 20. That's another pair, right? Look at this one right here. What do they give me in the middle? There it is. And just all right. Anybody else in the front? And then, of course, when you're done with that, when you do this, you get x plus 20 minus 5. And of course, that's going to be an old extraneoso solution. So that's why I kicked it out of there. You got the big bad boot. Any more in the front you want to ask about? Yeah. Number 8. You bet. 8. So again, I want to condense these. So I'm going to get log base 6 of x squared plus 7x plus 12 equals 1. So did you get to that part to start?
Yeah, I forgot the 7x's.
Whatever. Okay, so you want me to stop?
Can you
I-
do it?
I can, yeah.
Thanks.
So now I can go to exponential form. So it's 6 to the first power equals x squared plus 7x plus 12. So x squared plus 7x minus 6 equals 0 now. Okay. Now when I get to this, what am I going to do? Try to factor it. Okay. Now, does that one factor very well?
I think it should be plus.
Oh yeah. Wait, what's that? This is plus 6. Yeah, my bad. Yeah, this one was factors. X plus 6, x plus 1. So x equals -6, and x equals -1. And then I check them. -6, that would give me log base 6 of -3. Can't use that, so this is gone. Kick it. -1, oh, that's okay. +2, -1, up, +3. This one is good then. So one of the two was a good solution. All right. Okay, we're just about done. So why don't you go ahead? Here's what I'll tell you. I have the answers to all of these. So if you want to do extra ones on your own tonight and come in tomorrow and say, Mr. Snyder, could you tell me what the answer was to number 2? Yeah, I will gladly do that for you. For sure, though, make sure that the ones on the back, 9, 11, 13, 14, that you have those done. So when we come in tomorrow, we'll immediately go over those. Okay? Bless you. Okay, to this. Oh my goodness. See you guys. Thanks, you too.